Hey, Math 1. Today we are doing Chapter 7, Section 5. We're continuing to progress towards being able to do full geometric proofs. And today we're going to learn a little bit about proving proving that two triangles are congruent to each other. So let's get going. All right, so it says here, the objective is determine if two triangles are congruent or not in the most efficient way. So let's remember what congruent figures are. Congruent figures, congruent means equal measures. That's what the word congruent means. It means two things that have equal measures, right? Figures are congruent, measurements are equal. Congruent figures are two figures that have all equal measures. So, if congruent figures have to have all equal measures, then congruent triangles would be two triangles are going to be congruent if all three pairs of corresponding sides have the same measure and all three pairs of corresponding angles have the same measure. So that means all 6 parts of one triangle are congruent to all 6 parts of the other triangle. Right? Triangles have 6 parts. They have 3 sides and they have 3 angles. So 6 total parts. And the 6 parts of one triangle must be congruent to the corresponding 6 parts of the other triangle. And if that's true, then the triangles are congruent. Let's look at an example, and we are going to write small here, I think. I'm going to put a little line here. And I'm going to put a little dotted line here. And here we go. So it says, are the triangles below congruent to each other? If so, write a congruence statement. So we're going to learn how to write a congruence statement. And name all 6 pairs of congruent parts. All right, does it look like in these triangles that all 6 parts are congruent to all 6 parts? Well, I can't quite tell, but here's what I do know. I do know that side NP is congruent to side RS. Right? Those are both marked to be 35. Right? I guess I could write equals 35. I don't need to. The way you mark sides or angles congruent is with a little mark. So you can see I put a little tick mark on each of those sides showing that they are congruent to each other. So I have one part congruent to one part. I also know that angle M is congruent to angle Q because they are both marked to be 90 degrees, right? So they already have a mark in them. I'm not going to make a mark. But those are the 2 parts I know so far. I have 2 parts equal to 2 parts. How am I going to get all 6 parts equal to all 6 parts? Well, the first thing I'm going to try here is I'm going to find the missing side. I do not know this side length for MP, but because this is a right triangle, I can find it, right? I can use the Pythagorean theorem and find MP. And so what I would say is I'd say that 28 squared plus x squared equals 35 squared. I'm going to put a little dotted line there too. And so I'd go ahead and work that out. I'd square the 28 and get 784. And I'd square the 35 and get 1,225. Then I would subtract the 784 from both sides and get 441. And then I would take the square root of both sides and get 21. So MP is equal to 21. This side is 21. And now I see that MP is equal to QR. They're both 21. So I now have two sides equal to two sides and an angle. But let's look at this other triangle over here, this QRS. What about this side of the triangle? Okay, so if in the triangle on the left is a right triangle, and I have 21, 28, 35, then the triangle on the right, also a right triangle, so the Pythagorean theorem could be used for it also. And if I use the Pythagorean theorem, I would find out that this has to be 28, because 21, 28, 35 works for the other triangle. So therefore, I know that side MN must be congruent to side QS, because they're both 28. You could verify that with the Pythagorean theorem, but I'm telling you it's true. What about the angle measures? Are we familiar with the triangle angle sum? There is a theorem that says all three angles in a triangle add up to 180. I'll bet most of you knew that. So if all three angles in a triangle add up to 180, I can find the measure of this angle, angle N. Angle N would have to equal 180 minus the 90 down here, minus the 53.13. And if I go ahead and subtract those, 180 minus 90 minus 53.13, I find out that this is 36.87. Hey, that matches this angle over here. I now know that angle N is congruent to angle S. They are both 3687. And I think I could find angle R using the same triangle angle sum theorem, that they add up to 180. And if you do that, you're going to find out that this angle is 5313. So it matches angle P. Angle P is congruent to angle R. They're both 5313. So I, in fact, do have all six parts, all three sides are congruent to all three sides, and all three angles are congruent to all three angles. So these triangles are congruent. And I can write a congruence statement, and let's talk about that for a second. So a congruence statement is a statement that says two figures are congruent. Duh. This is the important part. When writing this statement, make sure you put corresponding parts in the same order. So let me show you what I mean by that. If I want to say that these two triangles are congruent, I'm going to start by saying triangle NMP is congruent to triangle, and then I'm going to stop and think for a second. So this triangle NMP is the triangle on the left. I need to name the triangle on the right in the same corresponding order. So N corresponds to what letter on the right? The N is the 36-degree angle, so that corresponds to the S. Over here, the S must come first because the N and the S correspond to each other. And then on the left, I have the M next. So the M must correspond to its letter. Well, the M corresponds to the Q. They are both the 90-degree angles. So I need to put the Q next. And then, of course, that leaves the P corresponds to the R. It is important that when you name the triangles, you name the three letters in corresponding order with each other. Okay. So I spent a long time on that, so we can go a little faster here now. All right, so we want to be able to prove that triangles are congruent to each other. And what we have just learned is that triangles are congruent if all 6 parts of one triangle are congruent to all 6 corresponding parts of the other triangle. However, you do not need to show all 6 parts are congruent. In fact, if you can show that 3 parts are congruent to their corresponding 3 parts, that is enough to say that the triangles are congruent. But, big but here, oops, big but, it must be a particular 3 parts. Not just any parts will do the job. Let me give you a quick example. Are you familiar with an equilateral triangle? An equilateral triangle is a triangle that has all 3 angles equal to 60 degrees. I'll bet you've seen that before. And it is certainly possible to have 2 triangles that are both equilateral, but they are different sizes. So they are not congruent to each other. All 3 angles are congruent to all 3 angles, but all 3 sides are not congruent to all 3 sides because one is bigger than the other. These are not congruent. So having 3 parts equal to 3 parts, the 3 angles equal to 3 angles, does not make the triangles congruent to each other. It is extremely important that you have a particular 3 parts equal to 3 parts. And if you do, then you can say the triangles are congruent to each other. All right, so we're going to look at a couple of these. The first one we're going to look at is called the angle-side-angle postulate. And it says, if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. And I have a picture of that situation here. I have, look how angle T is marked with 1 line, as is angle G. So that tells you that angle T is congruent to angle G. And angle R is marked with 2 little arcs, and angle C is marked with 2 little arcs. That tells you that angle R is congruent to angle C. That is how you mark angles congruent to each other with those little arcs. 1 arc for the ones that are the first pair, 2 arcs for the second pair. And on the sides, I have a little tick mark on TR. and TR is congruent to CG. Kind of. There you go. Okay, so I have 3 parts equal to 3 parts. Now it's important that you understand what included side means. Included side means the side between the angles named. For instance, in this case, side TR is between angle T and angle R, right? It's between the T and the angle R, angle T and angle R. All right, if this is true of 2 triangles, that they have 2 angles congruent to 2 angles, and the side between the 2 angles is congruent to the side between the 2 angles, then the 2 triangles are congruent. And we can write a congruence statement that says they're congruent. We can say that triangle TRW is congruent to triangle, I need to put them in the same order, T matches G, R matches C, and that leaves me with H, GCH. And just as importantly, this means that I get the other 3 parts congruent to each other for free. This means that I know angle W is congruent to angle H, even though it's not marked. Once I know the triangles are congruent, I get all 6 parts congruent to all 6 parts. The 3 I already knew, plus the 3 that I did not know yet. And that means that side TW would be congruent. Now notice, T and W are the first and third letter, so that would be the G and the H. GH. And side WR is congruent to side CH. Okay. So that is our first postulate. A postulate is like a rule or a theorem that says, if this is true, then something else is true. We've gone over a bunch of those. If the angle-side angle matches the angle-side angle, then the triangles are congruent. Notice, by the way, that the side is between the 2 angles. That's why it's got to be the side between the 2 angles. However, we have a second one on the back. This is also a rule, angle, angle, side. And it's really the same rule, except now the side is a side that is not between the 2 angles. So if the 2 angles and a non-included side on one triangle are congruent to the corresponding 2 sides and, oh, not sides, messed that up, angles and side of a second triangle, then the 2 triangles are congruent. So you can see over here, I have an angle equal to an angle. And I know this kind of got erased on your paper, got hole punched, but this angle is equal to this angle. And I have a side equal to a side. So I have 2 angles and a side not between them, congruent to 2 angles and a side not between them. And this is enough to say, therefore, the triangles are congruent. If angle, angle, side is true, then the triangles are congruent. That would be what this angle, angle, side postulate says. And so what would my congruence statement look like? My congruence statement would be triangle, we'll just call it JKL, is congruent to triangle. Now notice, the J has no mark, the C has no mark, so the J and the C match up. The K has one arc, the A has one arc, so the K and the A match up. And that leaves me with the L matching up with the B. And now I could name all 6 corresponding parts, but I'm not going to do it. We've done that twice already. I could name all 3 matching angles and all 3 pairs of matching sides, but I think we got that idea. All right, we're almost done. Look, it is important, in my opinion, that you make these little markings, the angle markings and the side markings. That shows that 2 parts are congruent to each other. However, there are 2 ways that you know parts are congruent, even if they're not marked. And if you know this, then you mark them. First is vertical angles. You know that 2 angles that are vertical angles will always have the same measure. So in a diagram, even if 2 vertical angles are not marked equal, you can mark them equal. Secondly is the reflexive property, which says a figure, an angle or a side, is always equal to itself. All right, so I'll show you how that works, but if you have an angular side that is the same angular side, it's obviously equal to itself. Let me show you that right now. So here it says I am supposed to state if the 2 triangles are congruent. And if they are, I want to state my justification. My justification is either they are congruent by angle, side, angle, or they are congruent by angle, angle, side. One of those rules, they're called postulates, one of those postulates, if they are true in a diagram, then the triangles are congruent. So let's look at example 1. In example 1, I have an angle equal to an angle. I have a second angle equal to a second angle. But it doesn't appear I know anything else. So are these 2 triangles congruent for sure? Well, I claim yes. And in this one, I'm going to use the reflexive property. This side down the middle is part of both triangles. And because of the reflexive property, it is equal to itself. Obviously, this side down the middle is equal in the left triangle to the same length in the right triangle. So I'm going to mark it equal to itself. And now, if you just look at one triangle, so I know this is weird, but I'm going to cover up this triangle. I have an angle, a side, and an angle marked. That is angle, side, angle. The side is between the 2 angles, right? So by angle, side, angle, these are congruent. Congruent by angle, side, angle. Again, I have an angle equal to an angle, a second angle equal to a second angle, and the side between them are equal. That is the definition of angle, side, angle. All right, example 2. What do you see in this example? Well, the first thing I see is, let's call this triangle 1 and this triangle 2. And in triangle 1, I believe this angle would equal this angle. How come? In triangle 2. Well, they would equal each other because they are vertical angles. So therefore, do I have enough to say they're equal? I have an angle equal to an angle. I have another angle equal to another angle. And I have a side equal to a side. So angle, angle, side. 2 angles and a side not between the 2 angles. That is one of our rules. If I have an angle, and a side not between them, then the triangles must be congruent. So these two triangles are congruent by angle, angle, side rule. Example 3. I have two sides equal to two sides, but I don't know any other angles. And I have no vertical angles, and I have no reflexive. I have no sides that are the same in both triangles. This one does not have enough information. Oops. Not enough info. All right, I'm going to go a little faster here. This one does have a pair of vertical angles. So can you tell? Look at one of the triangles. Look at triangle number 1. Oops, I need to put a second mark there because I already have one mark. Do I have two angles and a side that correspond to two angles and a side? I do. Is the side between the angles or not between the angles? Well, it is not between the angles. So these are congruent, and it's by angle, angle, side. How about number 5? I have 3 angles equal to 3 angles, but I don't know any of the sides. This one is not enough. I can't spell enough, apparently. Info. And number 6, again, the first thing I see is this side down the middle is in both triangles. So in this drawing, I have an angle here equal to an angle here. I have a side equal to itself, and I have a second angle equal to a second angle. So if I just look at triangle number 1, I have an angle, a side, and an angle, and they seem to correspond to the angle, side, and angle in number 2. These would be congruent by the angle, side, angle rule. The side is between the two angles. All right. One thing left and we're done. Thank goodness, I'm sure you're thinking. All right, so in this one, I want to state what additional information is required in order to know that the triangles are congruent for the reason given. So in this first one, well, the first thing I see is that this is equal to itself, so I know that automatically. I want to use angle, side, angle. So I have an angle, boom, those guys. I have a side, that's this guy down the middle. I need another angle, and I need this angle to be a particular angle so that the side is between them. So I need this angle to be equal to this angle if I'm going to use angle, side, angle, so that the side is between the two angles, right? Angle Q would not work. So I think what I need in this one is I need angle QCD to be congruent to angle FCD. I think that's an F, it got cut off. Maybe it was an E, I don't know. Do you see that? By saying that these two angles are congruent, I can now use angle, side, angle. Let's go to the second one. I'm supposed to use angle, angle, side. Well, I already have the angle and the angle, but I need the side. Now, can I use this side? I cannot, because that would be the side between the angles. And my side is not between the angles, because it's not, the S is not between the A's. So I need to pick a different side. I'm going to pick this side. So YZ congruent, let's see, that was the 3 and the 0, so that would be the MN. See how MN goes from the angle 3 to the angle with no markings, just like the Y is the angle with 3 to the Z, the angle with no markings. If those two were congruent, then I would have angle, angle, side. That is the additional information I need to use angle, angle, side. Do you see what I mean? By the way, in this one, you also could have done this side equal to this side, and that would have worked just as well. All right, last up, I have a pair of vertical angles here, so I can mark those. So I do have the angle and the angle, but what I do not have is the side. So the additional information I need is the side. Now, which side should I pick? I need to pick a side that is between the two angles. So angle W and angle V and angle K, I know that K got cut off, that's a K on your paper. I need the side between those two angles, that would be this side and this side. I need WV to be congruent to KV if I'm going to use angle, side, angle as the reason that those two triangles are congruent. That would be the additional information I would need to use that rule. Okay, I have finished. You have learned about congruent triangles. Good luck. I'll see you later.